So like I said, let's start looking at applying these formulas. The first question we have is that we are told that a medicine capsule is made up in the shape of a cylinder with two hemispheres attached to the ends like so, and they have given you the figure. Now obviously this does look like a medicine capsule. We know that medicine capsules look like this quite often. So we have been asked to find the total surface area of the capsule along with the volume of the capsule. Now let's just redraw the figure with all of the relevant details that we have. Now this is the capsule that is given to us. And notice I'm just going to draw a dotted line here. Because we are told that it is in the form of a cylinder with two hemispherical ends attached to the cylinder as shown in the figure. So it is obvious that the radius of the cylinder and the hemisphere will be the same. And we were told in the question that the diameter of the cylinder or of the capsule is 14 millimeters and that the total length of the capsule, so total length means this entire length, is nothing but 35 millimeters. And so we have to find the surface area and the volume. So now we will analyze this figure. If the diameter of the cylinder is 14, that means the diameter of the hemisphere is also 14, which means the radius in both cases is 7 millimeters. Now 7 millimeters is the radius. If the radius of the hemisphere is 7 millimeters, that means from the center to the end of the hemisphere, the tip of the hemisphere on both sides, it is equal to 7 millimeters. And so if this distance is 7, this distance is 7, this distance, which we are taking because it will represent the height of the cylinder, will be nothing but 35 minus 7 minus 7 or 35 minus 14 equal to 21. And now that I have all my dimensions, I will appropriately calculate the volume and the surface area. Now volume is generally easier. We can see that the volume of the figure will be equal to volume of the cylinder, because the entire cylinder is enclosed, plus the 2 times the volume of the hemispheres. Now, the volume of the cylinder, so the radius of each of them is 7 millimeters, and we got that the length or the height of the cylinder was 35 minus 14 equal to 21 millimeters. And so the total volume will be, formula for volume of cylinder, pi r square h. So pi r square h plus 2 times the volume of the hemisphere, 2 times 2 by 3 pi r cubed. Notice here I use the same r because they have the same radius. And notice that I did not put in any values right now, because this year you will get very large equations. So rather than putting the values in first and having to deal with a lot of different equations, it is better to simplify as much as you can and then put in your values. So what you can notice here is that I can take pi r square common and I will be left with h plus, this would have become 4 by 3 pi r cubed. So 4 by 3 r, because pi r square h is left here, pi r square 4 by 3 r would be left here. And now I will plug in my values, where pi, we'll take it as 22 by 7, which will be specified in the question. If it's not specified, you can choose whatever you prefer, into r square, which is 7 into 7, into h plus 4 by 3 r. Now h we calculated was nothing but 21 plus 4 by 3 into r, which is 7. This 1 7 and 1 7 can get cancelled. 22 into 7 is 154. These are values which will become very, very normal to you after doing many, many questions. And in the bracket we'll be left with 21 plus 28 upon 3, which I can write as 63 plus 28 upon 3. Now this will simply become equal to 154 multiplied by 63 plus 28, which will be 91, divided by 3 millimeters cubed. Now clearly here I can no longer cut my 3 because neither 154 nor 91 are divisible by 3. So you would proceed to simply multiply, divide to get to a decimal answer. I will leave that to you because that's not really something that's very difficult. But once you reach this stage, at least it's a lot easier than doing multiple divisions and multiplications. Now let's come to dealing with the total surface area of the capsule. Now if we understand carefully, the total surface area is basically the part that is exposed. So if I look at it carefully, my capsule, the curved part of the cylinder is exposed and the curved parts of the hemispheres are exposed because their lateral parts are basically covered on top of each other. My cylinder was there, I covered it with the hemispheres. So even their portions, their lateral portions, are not exposed outside. They are inside the capsule. So the total surface area in this case will be equal to the CSA of cylinder plus 2 times CSA of the hemispheres. Which will be equal to 2 pi r h plus 2 times 2 pi r square from our formulas. This shows you the power of the formulas. So again, like I said, I want to make it easier for myself. So I can write it as 2 pi r into h plus 2r, because 2 pi r h would be left here. This is 4 pi r square. So when I take 2 pi r common, it will be 2r left. And so when I substitute my values now, I'll get 2 into 22 by 7 into 7 into, in the brackets, h, which was 21 plus 2 times 7, which is equal to 2 times 22, 44, in the brackets 21 plus 14, 35, again now here millimeter squared. And so once again we can see that by combining the equations, by simplifying it, it reduces my number of calculations. This will of course be equal to 1540 millimeter squared. And so this is what you will be dealing with this year, where you will have to identify your shapes, identify what parts of the shapes are relevant to you, and proceed from there. Let's look at a couple more that are like this. So now we are given that we have a tent that is constructed in the shape of a cylinder surmounted by a cone. Now surmounted means that the cone is put on top of the cylinder, and we are told that it's in such a way that of course the radius of the cylinder and the radius of the cone are the same, in that the cone sits perfectly on top of the cylinder. Now if we imagine what that figure looks like, it will look something like this, where we will have our cylinder and on top of that a cone has been put. And so this is the tent that we have been asked to make. We have been asked to find the volume of the tent as well as the canvas required to make the tent. Now what that simply means is, a canvas is nothing but material. It's like kapda, it's like, just some fabric. So a fabric that will be used to make this tent, which obviously means I need to know the area of the fabric. Fabric is nothing but area. So basically they're asking us to find the volume of the tent and then for the canvas, the total surface area of the tent. Now let's first look at our measurements again. We are told that the diameter is 5 meters. That the height of the cylinder is 7 meters and that the height of the cone is 3.5 meters. So let's jump into the question. First of all, if the diameter is 5 meters, obviously that means that the radius is 2.5 meters. Or to make calculations easier, we take it as 5 by 2 meters. Now in this case, volume will again be straightforward. It's just the volume of the cylinder plus the volume of the cone. And so we'll have volume is equal to pi r square h plus 1 by 3 pi r square h. Now here I'm actually going to make two different h's, because although our heights, our radii are the same, the heights are not the same. So you don't want to confuse yourself, because here clearly the height of the cylinder, which is why I've taken it with the cylinder, is 7 meters, but the height of the cone is 3.5 meters or 7 by 2 meters. So now I can see that because radius is still the same, it's nothing but 5 by 2 meters, then I can still take pi r square common and I'll be left with h plus 1 by 3 into the h of the cone. Now we substitute our values. This would be equal to 22 by 7 into 5 by 2 into 5 by 2, because radius was 5 by 2, into height of the cylinder 7 plus height of the cone into 1 by 3. So 1 by 3 into 7 by 2. Now this would be equal to, let's say we cancel as much as we can right now. 2 and 22 get cancelled, left with 11. So the numerator is 11 into 25 upon 14. 5 into 5 is 25. And in the brackets I'd have 3 into 2 would become 6. I would take LCM. 7 into 6 would be 42. So 42 plus 7 upon 6. And now here I can see that I'll have 11 into 25 upon 14 into 49 upon 6. So simplifying as much as I can, 7 and 2 gets cut here, nothing else can be simplified further. So my final answer in fractions would be 11 into 25 into 7 or 77 into 25 divided by 12 meter cube, which once again you will just multiply, divide and get the decimal value. Let's now move to the canvas. Now again, logically if you think about it, if I am making a tent needs walls surrounding it and it needs a covering on top. It does not need any floor, which means the areas I have to consider are the curved part of the cylinder and the curved part of the cone, because the entire cone acts as the top, not the base of the cone. So the total surface area, which is the area of the canvas, would be equal to CSA of cylinder plus CSA of cone. Now here we remember that the formulas are 2 pi r h, again notice the capital H, plus pi r L. Now the problem is this L we do not know right now. We know the radius and the height of the cone, but not the slant height. So we will use the Pythagoras theorem to get the slant height L. And so this we first write as pi r into 2h plus L, where now we will calculate L, as we know that L is under root r square plus h square, which is under root 5 by 2 square plus 7 by 2 square. This will come out to be root 25 plus 49 upon 4, which is equal to 74 upon 4. Now when you get a question like this, you will leave your answer in terms of roots, because unless they specifically ask you to calculate it into decimal values. So we'll end up getting in our formula of pi r into 2h plus L, that's equal to 22 by 7 into 5 by 2 into 2 times 7 plus L, which was root 74 by 4. And so we will be left with our final answer, which is 110 upon 14 into 14 plus under root 74 by 4 meters square. So again, like I said, it's just a matter of analyzing your figure and figuring out what you need. Let's look at a slightly more complex figure.